There's a world full of secrets below the waves that you know. There is no light in the deep seas because of the pressure and darkness that rule there. This is the last frontier on Earth. It's a huge, mysterious area that covers most of the world but hasn't been explored much. Think of a place where animals glow in the dark, huge underwater volcanoes spew molten rock, and life changes to conditions we thought were impossible. The deep sea is a harsh environment where the impossible becomes real. It is a living laboratory of evolution. Let us check out what we know now about the deep sea. What's the plan for the future? How are things going? Let's start the video and answer these questions together. At a depth of about 200 meters, 660 feet, the deep sea is where light starts to fade. Due to its harsh conditions, such as low temperatures, darkness, and high pressure, it is the least visited biome on Earth. To stay alive, organisms that live in the deep sea have developed many changes, such as the ability to scavenge, hunt, and filter. Some of them stay alive by eating marine snow that falls from the surface into the deep sea. The bathyscaphe Trieste went down to the Mariana Trench near Guam in 1960. At 10,911 meters, it was the deepest place known in any ocean. Before 2003, the only ship that could reach this depth was the Japanese remote-operated vehicle, ROV Kaiko. The hybrid ROV Nereus went back to the Challenger Deep in May and June 2009 to do 3 dives to depths of more than 10,900 meters. The deep ocean has its own environment that depends on things like biology, light, pressure, salinity, and temperature. In the upper parts of the mesopelagic zone, light can't get into the deep water. Plants and algae can't live there because of the lack of photosynthesis, so energy has to come from somewhere else. Marine snow is an organic material that sinks. It is made up of tiny algae particles, debris, and biological waste. For every 10 meters of depth, the pressure in the water rises by about 1 atmosphere, putting a lot of stress on many marine life species. Larger metazone animals have been brought back from the depths of the ocean in excellent health thanks to traps with a special pressure-maintaining box. The saltiness of the deep sea stays pretty much the same, at about 35 parts per thousand. There are some small changes in saltiness here and there, but they are not important for the environment. There are big differences in temperature where the thermocline is, which is the line between shallow and deep water, and where hot water flows from hydrothermal vents to the deep sea bottom. Temperature ridges have different widths, and the tropics have the thickest ones. At any given depth, the temperature doesn't change much over long periods of time, and it doesn't change much from year to year. Due to hydrostatic pressure, the water temperature in geothermal vents can reach as high as 400 degrees Celsius. However, just a few meters away, it may drop to 2 to 4 degrees Celsius. The areas below the epipelagic are further split into zones. The bathyal zone, which is also known as the continental slope, is the lowest and consists of parts from both the shelf above and the gulf below. It is 200 to 3,000 meters below sea level. The abyssal zone, which is between 3,000 and 6,000 meters deep, and the hadal zone, which is between 6,000 and 11,000 meters deep, make up the deep sea below this zone. Food comes from marine snow, which is falling organic matter, and bodies from the productive zone above. It is hard to find both in terms of where it is and when it is. Many deep sea species don't rely on gas to float. Instead, their meat is mostly made up of glycosaminoglycans, which makes it jelly-like and very light. Also, deep sea squid often combine their soft tissue with a flotation tube full of a coelomic fluid that is lighter than the water around them and is made up of metabolic waste ammonium chloride. The fish that live in midwater have changed in ways that help them survive. They are small, most of them are less than 25 centimeters, 10-inch long, and they eat a variety of foods. They also have slow metabolisms and don't like to waste energy looking for food. Their bodies are long and their muscles and bones are weak and slippery. Often their mouths are hinged and can be extended, and their teeth are recurved. It's hard to find a partner to breed with because there isn't much light, things are spread out, and many animals are hermaphroditic. Because there isn't much light, fish eyes are often bigger than usual and have only rod cells. Because they can see up, they can look for the silhouettes of animals that might be food. Prey fish, on the other hand, have changed in order to survive being eaten. These changes are mostly about hiding their shapes, which is a type of disguise. This is mostly done by reducing the size of their shade by squeezing their bodies together on the sides and using bioluminescence to light up the area around them. This is done by light coming from ventral photophores, which tend to make light that is bright enough to make the bottom of the fish look like the light in the background. Some fish have a retroreflector behind their retina that helps them see better in low light. Flashlight fish have this, and photophores, which they use to find other fish that are shining their eyes. Living and dead biological matter that sinks at a rate of about 100 meters per day is almost all that organisms in the deep sea eat. In addition, only 1% to 3% of what is made on land makes it to the seabed, where it mostly forms marine snow. Larger food falls, like whale bodies, also happen, and studies have shown that they may happen more often than we think. There are a lot of animals that eat mostly or only when big chunks of food fall to the ground, and the distance between whale bodies is only about 8 kilometers. Along with that, there are some filter feeders that eat biological matter with tentacles, like Fraiella elegans. Even though they live in very deep waters, humans still hurt the animals that live there. The London Convention is meant to keep waste like sewer sludge and radioactive waste from being dumped in the ocean. A study found that between 2007 and 2011, there was a drop in deep-sea coral in one area. This drop was caused by global warming and the acidity of the oceans, and biodiversity was thought to be at its lowest level in 58 years. Ocean acidification is especially bad for deep-sea corals because they are made of aragonite, a carbonate that dissolves easily, and they grow very slowly. It will take them years to heal. Trolling in the deep sea also hurts wildlife by destroying habitats that can form over years. Mining is another thing that people do that has changed life in the deep sea. One study found that fish populations at one mining site dropped after 6 months and 3 years, but they rose again after 26 years to the same level they were at before the disruption. To live in the deep sea, where there is a lot of hydrostatic pressure, deep sea fish have changed their proteins, body structures, and metabolic systems. Even though things like having access to food and staying away from predators are important, deep sea creatures must be able to keep their metabolic systems well regulated even when they are under a lot of stress. Because they live in harsh environments, these creatures have developed special traits to help them survive. Proteins are greatly affected by high hydrostatic pressure because they change the way they are organized with water during the binding reactions of hydrating and dehydrating. This is because most interactions between enzymes and ligands are charged or neutral non-charge interactions. Because hydraulic pressure changes both how proteins fold and assemble and the activity of enzymes, the deep-sea species have to make changes to their bodies and structures to keep their proteins working even when they are under pressure. When it comes to protein replacement, it was found that deep-sea fish that are under a lot of water pressure have a lot of certain osmolytes. It was found that trimethylamine N-oxide, TMAO, levels rose with depth in some chondrichthyons, taking the place of other osmolytes and urea. Because TMAO can protect proteins from high hydrostatic pressure, which can make proteins less stable, adjusting the osmolyte levels is an important way for deep-sea fish to deal with high hydrostatic pressure. Deep-sea organisms have molecular changes that help them live and do well in the sea. The osteocalcin burlap gene in Mariana Hoddle snailfish changed, and it was found that the gene ended too soon. The osteocalcin gene controls bone growth and tissue mineralization. The frameshift mutation seems to have caused the open head and bone formation from cartilage. High hydrostatic pressure in the deep sea makes it so that organisms that live on top can't build closed skulls that can handle the stress. In the same way, normal bone changes that happen in surface vertebrates can't maintain their structure when there is constant pressure. People think that more is known about the moon than the deepest parts of the ocean because of something George E.R. Deacon said in 1953. This statement was mostly about how little information there was at the time about the seafloor's depth. Another dangerous and risky idea is that more people have stood on the moon than in the deepest part of the ocean. Because of the high pressures in the mesopelagic area, the deep sea is still one of the least explored places on Earth. To look into the ocean's depths, people use traditional means like baited camera stations, small manned submersibles, and remotely operated vehicles, ROVs. But because studying in this zone is hard and expensive, not much is known about it right now. Pressure rises by about 1 atmosphere for every 10 meters. This makes it hard to get to deep-sea places without using machines and to study the animals that live there. The deep sea is a huge, strange place that keeps making us think about how life works on Earth. Its strange ecosystems, strange animals, and constant threats from people show us how much we still need to learn about our homeworld. By learning about the deep sea and the creatures that live there, we can understand how important it is and work toward a better future for both people and the amazing creatures that live there.